Okay, so let's go to our presentation that we were dealing with before. We did looked at a single coded example, and last time around we were looking at we also briefly looked at 2 lectures ago. We briefly looked at a grade list data structure. Now that grade list could be anything. It could be, oh, are we going to keep some assignment grades different than the quiz grades, which is different than this, which are different than that. Or we could just say it's just a bunch of grades and I want to be able to calculate the average and they're all considered the same. The question was intentionally vague to get you thinking through how data structures work. We're going to implement this thing, or I have implemented this thing, for just a box full of different grades that are all created equally, and I just calculated the average. Okay, that's the easy version of it. Uh, and we can also look at the mover class if you wanted to, but I wanted to leave this open for you guys to try something out. So we will have an example of this mover class in the zombie solution files that we have for the lab. I also talked about the fact that I don't want other people to be able to change my data. It's my data, damn it, get out. Do not change my data on me. In fact, you will see that with something like a name. You shouldn't be allowed to change my name on me, or you need to have the right permission to change my name on me, not rather than just like modifying the data. And I'm hoping you guys aren't hearing my boys screaming in the background of this video. I'll have to listen for that later. Uh, you might hear all sorts of conversations. Sorry about that. So what we have is, wow, they're loud. Anyways, what we want to have is we want to organize our data so that the functions match with the data and that we're arranging and organizing our data. Very much like, where do I put my tools? I put it in my tool area, my workshop, if you will, in the basement. We don't have our stuff thrown around, strewn around willy nilly like my kids do for the basement. I have dedicated places. I go to the dining room to eat. I go to the kitchen to cook, right? Now that might be due to the fact that there's an oven there, but I have and we normally specialize or make special areas, right? You should not be studying on your bed. Okay. Uh, so we're going to look at creating a class, and we have 2 different ways of creating a class. Uh, and so the functions are wrapped in the class. We will often have things like this, where we have this colon thing, and we're going to see this pretty much right now. At least I hope we are. That's the plan. Uh, where in our CPP file we have the function, we have the prototypes, the stubbies, the I owe you this header file, this I owe you this function stuff in the header file, and then we actually define things in our .cpp file. Uh, we will have all these functions available to us, and we will be making what are called getters and setter methods. We have getters and setters methods because essentially we have getters and setter methods because the variables most of the time should not be available for everyone to modify, right? My name should not be modified by random other people. I should have some advocacy on how it's modified, what happens. When we talked about setting ID, if you give me a garbage ID, I should be able to handle that error event, right? One time, one place, in an intelligent way. And so what I really want to have is I want to go through these methods to set things. If, and everyone will try this, a bunch of you will try and make everything public, right? I don't know what's going on with that variable. I'm going to make all my variables public. And now you can go and you can modify that variable to your heart's content. And now you're essentially working in, well, actually, you're working like it's just like C code now. We have a bunch of functions, you have a bunch of variables in some kind of structure like thing, and you just stomp on or change what those variables do. There's, if you want to have something that looks like C, that's the way to do it, right? You make all your variables public, and you're right back to what a struct does. You just stomp on what's in the struct. You change the values in the variables directly. The only difference is instead of you have a function that is also in the struct, right? If you make it public, it's like leaving all your doors unlocked because you don't want to find your keys, right? You can imagine it's short term very convenient, but long term it's a really bad decision to make, right? You've allowed anyone, everyone and anyone to modify any of your data in that structure. And that may not seem bad, but that's actually the kind of things that people look to exploit when it comes to hacking a system, or the kinds of things that will bite you when you later on find out, oh, that's why you don't do that, because I have some piece of code in some other file somewhere else that's just stomping and changing my variables, and I had no idea it was doing that. Essentially, your brain is limited. Everyone's brain is limited. We only have a certain amount of, you know, cognitive ability. If you do not have some kind of discipline here, what you end up getting is just pure chaos in your code, and that's what we're trying to teach you, is that discipline. Okay, so we can add all of our code in one file, which is what student 2 class was. The multiple file version of it is actually multiple files, not multiple CPP files. So multiple file, we actually multiple CPP files, because we also have our main file. We, for every single class, what we're going to do is we're going to make a .cpp file and a .h file. The .h file is for just, here are the functions I'm going to have, here are the variables that are going to be available. You may not be able to access them or modify them, but that's what they are. I personally don't think that the publicly visible variables is always the best thing. Java doesn't even allow that necessarily. You just pass in an interface. But in CPP file, your CPP file is where you actually implement everything. So your header file is just your prototypes, just the single line thing saying I owe you this function, and the actual implementation is in your .cpp file. The point of this is your .cpp file is not shared with others. Nobody needs to see it. No one needs to know how you implemented your sorting function. No one needs to understand how you did your let's say how you implemented set name. No one needs to see how you did all of this stuff. We do actually, but what other people using your code don't need to see this. But what they need to know is, what's the name of the function to call? What functions are available to me? That's what the header file is for. So it allows me, the header file allows me to know what's available to me, what functions I can call, and the CPP file is how it's actually done. So any file name, so it must be declared before we use it. So what we're going to have is our C files or CPP files are going to include those header files, like standard IO, for example. The header file is a declaration of the functions and variables, and so you would include that that header file. And so, and we essentially have a table of IOUs, and I like Dumb and Dumber. I'm sorry, maybe I'm juvenile. Right? You're talking about with your header files. You're saying, I owe you these functions. If they're not implemented, everything will compile they'll almost compile just fine. Right? And then you'll get a linker error, which are really hard to track down, by the way, later on. So you say, I owe you a function called setName. I owe you a function called setID. If you do not implement those functions in a .cpp file, then you're going to have, then it's going to, barf on you when you get to the linking stage, not the compilation stage. So here would be an example of a very, very simple example of what we could do. So we'd actually, what we should have, so here's test. It's, let me see here. I want to look at my code. So example one, here's my test. It's just, this is just in my main method. I have main, it calls test. Great. That's really not that useful. Here's the different approach. Here's test.h. I have an IOU called test. Test.cpp should also include test.h. I'm going to get this question. Oh, there is test.h included here, but we're going to include it for both the CPP file and the header file for a reason. So when we have a test, when we have this header file, how does main know that this function exists? Well, it includes test.h, which has, hey, by the way, I owe you some function called this. What about the CPP file? Well, the CPP file, well, actually, this is closer to the other way around, but what does the CPP file do? It's going to include test, and so they're going to be able to hook up this, and this hooks up to this, and so everything's sort of hooked up together. We're going to look at, I'm going to refactor Rec 2400, but before I do this, I want to show you what we do with student instead. So let's keep this and let's look at what the student class had last time around. So here's our student class from last time, right? We had everything in there. I had a class, I had some private variables so that other people cannot just modify my name. It's private to me, the object, not for anybody else. It's for me, for my purposes. I have public functions, which include two constructors, a destructor, a get method, and a set method. Fine. What I want is we're going to look at the student. Instead of just calling it stu2, we're going to do this one. All right. So here is my header file. So the pragma once is the new, in, I like it, version of how to include things. By putting that one line up there, it means it's first come first serve. The first, my student main.cpp, let's see what it has. Hey, it has student.h. Great. So it's going to include student.h. How about student.cpp? What does that look like? Oh, it's also including student.h. Which one's going to be compiled first, student or student main? I don't know. There's no way of knowing. C and C++ do not have any particular order in which they do the compilation, or you don't want to sort of guarantee these things. So I try and compile the student, or I may try and compile student main. I don't know which one's going to be included. Both of them are including something called student.h, which are going to be stuffed at the top of whatever file is including this. So student.h, the contents of this, the whole thing, like this, is getting dumped on the top of this or on the top of student.cpp. One or the other. More importantly, when this is being dumped on one or the other, if I got rid of this line right here, let's comment it out, it's going to blow up, or it should. I really hope it blows up. Oh, it's going to blow up the hard way then. This possibility doesn't blow up, but I think it's going to. Oh, it didn't blow up, surprisingly. It can blow up. The reason it can blow up is if I try and include, where am I right now? Student.h, okay. Student main is going to include student.h. Student is going to include student.h. And since they both have the same thing on the top of their files, if there's any kind of weird, like, which one are we doing first? Or I have two copies of this same class. If there's any kind of ambiguity of how things get resolved, it's going to say I have two copies of the same file. Student, this student.h, all of this content right here is being stuffed on the top of this and stuffed on the top of this. And if there's any kind of discrepancy, or if there's any kind of, it can be a case where you don't know which student you want in this case, and it won't allow me to build my code. I need this pragma once to mean that I only include student.h once in my entire program. And we'll go over it again a bit more because this requires repeat discussions. Every CPP file tries to be built separately. The first one to include student.h gets it at the top, and then later on everything gets linked up. So it's a first come first serve for whoever gets student.h, but they all know about student.h, and they're able to make sure that it's only included once and that everything knows about everybody else. So I'm going to have to stop the video soonish, but let's have a quick look at what this ends up doing. So here is my student.h. It looks very similar to my other version of it, but notice I don't actually have the implementations. I just have these little, I owe you a function named student, I owe you a constructor, I owe you a constructor named student that takes in two parameters. I haven't made those yet. I owe you a destructor named student. I owe you a get ID, a set ID, a set name, and a get name. These are the things I owe you. And then, so I could call all of these functions if I want. So I'm calling the constructor, the blank constructor. I'm calling the constructor with two parameters. I'm going to get the name from the object itself. I'm going to get the name from this object itself. I'm going to get the ID. I'm going to just try and directly stomp on, well, actually we can get rid of this one maybe. We'll look at that in a second. Um, should I have access and the ability to just stomp on somebody's values? Turns out, yes, I can if I do this, and so we'll look at this in a second. I shouldn't be able to, but I can in this case. Just like last time, I will have a, should look almost exactly like my previous iteration or my previous implementation of student. It looks almost exactly the same. The only difference is I have this in front saying, where is this defined? Oh, it's defined in student.h. So I'm going to go in the student class, which is in student.h, the student class. That's what I'm implementing. I'm implementing I am implementing the student function or the student constructor from the student class that is in student.h. Yes, I'm going to say student more. Right? I'm implementing the student constructor from the student class. I'm implementing the student destructor from the student class. I'm implementing get ID from the student class. I'm implementing set ID from the student class. Remember I said there were IOUs? Let's make it an IOU. All right, let's do this. You'll see some. Does it build? It actually builds. Oh my god, that's bad. Okay, let's. I have notice, and it builds. So just because it compiles, hey, it's great, it's fine. Notice we have an underline here. It says set ID has not been defined. No one's ever defined it. It's actually in student.cpp where the definition was, but I commented this out. I commented this out. I have a function here that I owe you called setID. I want to make sure student main, do I have get ID? Let's do a set ID for student. P stu set ID, and I'm going to set the ID to 4000. Let's say 40, just to be something different. All right, let's compile it. All right, there we go. Good luck finding this. What's going on? Well, it's an external symbol. Set ID is not defined. What's going on here? Well, I commented out this chunk of code. Let's put it back in and see what happens. But it means I can merely think I have a function. It's in the header file. I owe you one function called setID. I did not implement a function called setID when I commented this. When I commented this chunk out, I did not implement that function, and ergo, I have a compile issue. Okay, I need to take a quick break. When we come back again, we'll look more at the actual making a object across multiple, making a class across multiple different files. All right, thank you everyone, and I'll talk to you very, very shortly.